Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. The spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
Is everything else working? Is the probe where we think it is in space? Is it pointing in the right direction? Things like that. It's no science data yet.
What if the farthest object ever built by humanity is still traveling with no destination, no rescue, and no way back? Nikki Fox, NASA Science Mission Directorate, once said, "Flying this close to the Sun is a historic moment in humanity's first mission to a star." That quote was about reaching inward, toward a star. But today, we are going to explore the opposite journey. A mission that is moving outward into the unknown. A machine that has already left the Sun's influence. A signal that takes nearly a full day just to reach Earth. And a journey that could continue for millions, even billions of years. So the real question is, how far can Voyager 1 actually travel? And what happens when it finally goes silent? Picture this, it is 1977. Humanity is still taking its first serious steps into space. And yet, engineers are preparing a mission that will go farther than anything ever built. Voyager 1 was never meant to last this long. Its original goal was simple: explore Jupiter and Saturn, gather data, and then fade into history. But something unexpected happened. The mission did not end. It evolved. Over decades, Voyager 1 kept going farther and farther, until in 2012, it crossed a boundary no human-made object ever had before. It entered interstellar space, the region between stars. And that is where the real story begins. Because once you leave the Sun behind, you are no longer just exploring space, you are entering the unknown. Have you ever wondered how a spacecraft launched in the 1970s managed to go so far without running out of energy early on? The answer lies in timing, perfect timing. Voyager 1 launched during a rare planetary alignment, something that only happens roughly once every 176 years. This alignment allowed the spacecraft to use gravity itself as a tool. As Voyager 1 approached Jupiter in 1979, it didn't just observe the planet. It used Jupiter's immense gravity like a slingshot, accelerating and redirecting its path. Then came Saturn in 1980. Another close pass, another boost. But here is where everything changed. Instead of continuing along the flat plane of the solar system, Voyager 1 was redirected upward, toward deep space. A deliberate decision made to study Saturn's moon Titan more closely. That one choice sealed its future. It meant Voyager 1 would never return. It would not orbit the Sun again. It would not slow down. It would leave. And along the way, it delivered discoveries that reshaped our understanding of the solar system. Massive storms on Jupiter, active volcanoes on Io, and complex ring structures around Saturn. But none of those discoveries compare to what came next. Because eventually, Voyager 1 reached the edge of something invisible, yet incredibly important. And crossing that boundary would change its identity forever. Estimated read time 3 minutes. Now, imagine a boundary you cannot see, but everything changes once you cross it. This boundary is called the heliopause, the outer edge of the Sun's influence. Inside it, the solar wind dominates, streams of charged particles flowing outward from the Sun. Outside, that influence fades. In 2012, Voyager 1 crossed that line. For the first time in history, a human-made object was no longer in the Sun's domain. It had entered interstellar space. And the environment changed instantly. The solar wind weakened. Cosmic radiation increased. The familiar became unfamiliar. Communication became more difficult too. Signals traveling at the speed of light now take over 22 hours just to reach Earth. Think about that for a moment. Every command we send, every piece of data we receive, is nearly a full day delayed. Voyager 1 is no longer nearby. It is operating on the edge of human reach. And yet, it keeps sending information back quiet signals from a place no spacecraft had ever explored before. Even as it travels deeper into interstellar space, something else is happening, something inevitable. Voyager 1 is slowly running out of time. What happens to a machine designed for a few years when it survives for decades? It begins to fade. Voyager 1 is powered by radioisotope thermoelectric generators, systems that convert heat from radioactive material into electricity. Reliable, long-lasting, but not infinite. Each year, a little less power is available. So engineers had to make difficult decisions. Instruments were turned off, systems were reduced, functions carefully prioritized. Step by step, Voyager 1 has been shedding parts of itself just to keep going. And even then, challenges continue. Signals sometimes become distorted. Data can appear incomplete. Radiation and age are taking their toll. Yet somehow, it still responds, still sends back data, still communicates across billions of kilometers. But not forever. Within the next few years, Voyager 1 is expected to lose its ability to communicate entirely. Its signal will fade and eventually stop. And when that happens, something profound occurs. Voyager 1 will continue its journey, but in complete silence. Which brings us to the biggest question of all. If nothing stops it, how far can it actually go? Let's put this into perspective. Voyager 1 is traveling at roughly 61,000 kilometers per hour, fast enough to circle Earth in minutes, yet in space, that speed is just the beginning. Because space is vast beyond intuition, in about 40,000 years, Voyager 1 will pass near another star, Gliese 445, not land, not stop, just pass by, like a drifting messenger. Voyager 1 will not arrive anywhere. It will not complete a mission in the traditional sense. It will not return. Instead, it will continue endlessly. A small machine from Earth, moving through a vast and silent universe. Its journey is no longer about exploration alone. It is about legacy. Because even when its signal fades, even when it can no longer communicate, it will still exist, drifting, traveling, enduring, and maybe, one day, passing close enough to something or someone to be noticed. So the next time you look up at the night sky, remember this: somewhere out there, beyond what you can see, Voyager 1 is still moving, not toward a destination, but into forever. And that journey might outlast us all. If this made you see space a little differently, consider subscribing, because there is a lot more out there to explore.